Good afternoon, everyone, and welcome to Improving's Virtual Lunch and Learn. Before we get started, I want to inform you about a feature in the presentation that'll make the session more interactive. Take note, in the right-hand corner of your screen, there's a question mark icon. If you click that icon, it'll allow you to enter a question in the question and answer feature, which I can then deliver those questions to the presenter at the appropriate time. Without further ado, we're excited to have Eric Ziebenich, a principal consultant with Improving, who's going to be sharing with us front-end state management. Eric, the floor is yours.
Hi, as Max said, my name's Eric Ziebenich. I've been doing front-end development now for the better part of about 4 years, I think. And so I've had the joy of learning and watching the state of front-end development mature and grow. And one thing that a lot of developers get hung up on is state management. Every application ends up needing state management at some point, whether it's a React app, an Angular app, a Vue app. They're all eventually going to need to do some sort of business logic in the front end. And I started noticing that there weren't a lot of standards, and there was a lot of opinions, and a lot of people had opinions, and a lot of them were conflicting. And so I started kind of gathering up some of the more generic opinions and refining those to kind of understand better where to try and come up with some sort of best practices over state management. So let me make sure I'm there. Okay, so what is the point of global state management? We want to abstract our business logic from rendering logic. So in our front ends, we render views for the user. And often we want to accept interactions from the user so that we can tell our backends what to do. The rendering logic is very dependent on your business and how you want that specific page to interact with the user. Whereas your business logic is not specific to that specific implementation. Amazon, for instance, right? They have a shopping cart, and a shopping cart has items, has items in the cart. And that's business logic. Now, how we render the shopping cart, whether it's a little mobile cart up in a little drop down, or a full page cart, or through their one-click checkout stuff. That's 3 different ways of rendering the same business logic. So we want to be able to take our business logic and separate that from our rendering logic. We want to be able to access data from anywhere in the application. We, just like that shopping cart, I don't want 3 copies of the data necessarily. I want to be able to get the cart data and add something to the cart without having to go add it to that cart and this cart and that cart. That way, we have one place of doing logic. We have one place we need to test. We want deterministic rendering. If our cart has data in it, we want it to render the same every time. If someone adds something to our cart, we want our pop-up cart to change, and we want our full page cart to change. We don't want to have to explicitly tell those views to update. We just want it to happen. And we want deterministic state reproduction. As your application grows, eventually it's going to come to a point where things start going wrong. And if you've ever dealt with clients, they often can't describe accurately what they were doing to cause the application to fail in the way it did. So it makes it very difficult. Personally, I've had clients try and explain to me what page they were on when it failed, and they're talking about some page, and it's like, can you just send me the URL, because the words you're using don't make sense in the application logic. And then trying to get them to be like, what exactly did you do? And they're missing steps, and they're like, oh, I filled out the form and hit next. And it's like, well, yes, but how did you fill out the form? Like, Did you click on this 5 times? We don't know. So being able to record that and view it gives us a way to say, we don't need all that, just give me this little snippet and I can go figure it out. So what is global state management not? It is not a replacement for application state, right? Our global state management, our application state and our global state are different. Some parts of our application state are not global, right? UI logic, like whether or not a modal is open, whether or not, what the status of a text field is, right? The data in there, that isn't global state. That is still application state that we need to manage through our application, whether it's to a data binding with Angular, use state with React. Those are separate. Global state is for business logic. Global state management is not complicated. The goal is decoupling. It's this big scary thing, and a lot of people are scared of tools like Redux or RxJS or things like that that allow you to decouple. But really, it's just decoupling, and it's putting some business logic separate from our rendering logic. It is not Ajax. There's this common misconception that global state management is Ajax. And it's like, well, Ajax is this other thing that gets data from a server, but global state management is our state in the front end. And it's not the only source of truth, right? It is a source of truth, but it is not the source of truth. So one of the major things we want is deterministic rendering. So I realized that if you've done Redux, you've seen these 4 before. The reason I pulled these 4 is I looked at a lot of state management libraries, and regardless of the state management library, the benefits that they expunge are always come back to these 4 tenets. And Redux did a really good job labeling them, so that's why I'm using the labels. And the things that front-end state management libraries like Redux or RxJS give us are predictability, centralization, debuggability, and flexibility. And if you're looking at front-end state management libraries, find one that has these, that gives you these, because they're necessary for non-crazy global state management. These make it maintainable. So let's talk about why these are important. So let's say we have a test that looks like this, given a list with to-dos in it. When adding a new to-do, then the list has the existing to-dos and the list has a new to-do at the end of the list. Can we write a test? Yes, it's beautiful, right? Given when then style unit testing makes tests pretty easy. And then how can we be sure that our test for this logic accurately represents our real world usage? And the answer comes down to, we need to separate it. We need to be able to test this code and trust that this code works. And then we need to render that and trust that if the data is there, it will render correctly. So when we do that, we're writing, stand by. That's not the right screen slide. There it is. When we do that, we're writing a test for our business logic. And then we can also go write a test that goes, hey, if there's a list of to-dos, it renders. I don't now need to also write a test that when I click this, it goes and updates the state and the state has all this stuff. I can just be like, hey, when I click the button, it says add a to-do, and I've already tested my business logic separately from my rendering logic. That gives us, what does that give us? Yes, that gives us predictability. Starting from a given state, manipulating the state should produce the same result every time. So that's also happens to be the definition of a pure function. Again, Redux, all your reducers are pure functions because it guarantees the predictability of your state transitions. They're testable, they're verifiable. They also tend, this unit test here is something that you can show your product owner and be like, hey, is this correct? Is this the logic you want? And they can read this and go, yes, this is exactly what I want. They can also read it and go, oh, and also I want to make sure that the date is correct or the timestamp is correct and that the status is uncompleted. And those two words are, two more lines on the and you go in and you give two more thens and your test works, and you can verify with your product owner that that test works the right way it does. Once you've written that logic, if you're using it, if you click any button anywhere and you add a to-do, that all that logic is the same. You don't have to repeat yourself, and you get a lot more predictability in your application. Another scenario, you get a bug report from an important user claiming your application's broken. They send a screenshot of the generic "oops, an error has occurred" message and a vague description of what they're doing at the time. Your boss pings you and asks for an ETA. Where do you start? How do you know what went wrong? How do you know the user's describing their actions correctly? Did they leave a step out, right? Users are not technical people. They don't understand the complexity of what goes into the application and why errors can happen. They just know they were using it and a box popped up and said contact tech support. If you're not using global state management and you're just doing everything from within the application, it's very hard to take your dev machine and reproduce up to a point that you can go, okay, I'm where the user was. Now I want to test out what they said they did and try and reproduce. You have to guess. With global state management, you could, in your error message, record the state of the application and send that along as part of the error message, and then you can just paste in the state and be like, cool, my application is in exactly the state that happened when this error occurred, right? I have all the data. That gives us debuggability. You want to record the actions that manipulate the state so that you can replay them, right? It's repeatable, it's explicit, it's accurate. You have all the things you need to replay the user's interaction so that you can debug it. Another scenario, you receive a request to implement undo redo. It's a hard thing. If you've ever done undo and redo, they're very, very difficult. You end up having to store every action and then undo, and you end up with a stack of actions. For doing global state management, you have one place that records all of it. Additionally, you have one store that you can persist. You have one store that you can go look at and get a global overview of your application state. I can't tell you the number of times that I've been dropped on a new project and I get to the cart page and I want to see, the item GUID of that cart line item, and you're like poking through HTML, hoping that someone used it as an ID, or trying to use the React dev tools and maybe they passed it in as a prop somewhere, or you end up going and having to write a console log that logs it. If you had a global state, you could just access the global state and look at it and see what cart line items there are. Right? Again, there's one place to test and verify. You'll notice that a lot of this is talking about testing and verification, because that's what the business cares about. They don't care what front-end framework they use, whether it's Angular, React, Vue, Svelte. Like, that doesn't matter. What matters is, does the application perform the business logic correctly, right? An abstraction. It abstracts you away from the React way of doing things or the Angular way of doing things because of our next point. I don't know if you've ever been a part of a company that swaps a CTO or swaps the key stakeholder for the developers and decides that they have a vendetta against the front-end framework that you're currently using and mandate that we're switching to this, and everyone's like, why are we doing this? And they're like, because I said so. And you're like, well, I guess we're doing it. it sucks. It sucks to sit down and have someone turn around and tell you, hey, we just spent 8 months rewriting the mobile app and we don't like GCP, so we're going to move to Angular or move to AWS. And then you're like, well, I guess we're rewriting the mobile app, right? It's going to take another 8 months. Same thing can happen with front-end frameworks. Switching from React to Angular or from, Knockout to React, if your business logic is encoded in the front-end framework you're using, you have to rewrite the business logic, retest the business logic, and redo everything. If you abstract that out into a separate layer, global state management, you get to save all that because it's not dependent on your front-end framework. It gives you the flexibility you need, right? So I like Redux. It works. It's simple. They have plugins. There's a huge community. That's what I look for in a framework or in a library. Like, go pick something that's popular and has lots of support and lots of Stack Overflow articles, because it doesn't matter whether you're writing Angular or React or Vue or Svelte. Those apply to your library, and then you only need to relearn the hook for Redux, React Redux or NG Redux, or I guess Vue Redux if that exists, right? Again, RxJS, right? There's hooks for Angular for RxJS. There's hooks for React with RxJS. Once you hook it and you have all your logic out of it, you can swap the front end and the render, and all you have to do is be like, hey, here's a button, and when I click it, I send the action, or here's the button, and when I click it, it updates the observable. It's super easy to swap your front end. And even if you aren't rewriting your front end from technology to technology, like being able to turn around and say, hey, we want to try out a new landing page that has a new lead form on it. Being able to just spin up a landing page that has a new form on it and call submit and says, hey, here's the data to the global state. It saves you a lot of time of having to re-implement the business logic in your new landing page. So earlier I said it's not the only source of truth, and now I'm talking about single source of truth. So the single source of truth, these are the tenets. The reason we want a single source of truth is because of this triangle here. I don't know if you've seen this triangle, but it's fairly common. You've got maintainability, speed, and size. And somewhere in your application exists within this triangle. You can take your application and you can make the bundle smaller. You have really good size. If you make the bundle smaller, you're sacrificing your speed and your maintainability. Same thing. You can make your JavaScript execute incredibly fast. You're going to be sacrificing maintainability and your bundle size. You're going to need more code because you don't want function calls and stuff like that. Or you can go maintainability and you're going to increase your bundle size and make your JavaScript a little bit slower, right? Somewhere, it's all about finding a balance between these three, right? Obviously, if we just blow everything out and we have everything 5,000 line long components, the bundle size is going to be huge. Is it really that much more maintainable? Probably not. So generally, I like to be somewhere about here. I don't know if you can see my mouse. If you can't, to the northeast of the triangle. So we're talking about front-end state management, right? So we're talking about a front end, whether it's React, Angular, the C# front end that's on for desktop apps, whose name I can't recall right now. Anyway, front end. It's not the server. You're not doing insane math. If you are, that's fine, and that's a sub case, right? Then you might want to care about it. But most websites are a view to view data, and then when you interact with it, it sends it off to the server, and the server does a whole bunch of number crunching and then sends a result back. The server is what matters. So oftentimes, developers get hung up on speed and size. And it's like, oh, I don't want to use Lodash because it's slow. And it's like, well, it's one more call than the array version. It's cleaner, and you don't have to wrap your code in a bunch of if statements. Or, oh, I don't want to include Lodash because it includes a whole bundle. And it's like, surprise, Lodash is already in your application. If you're using a modern front-end framework, Lodash is in there. Use a bundle explorer and you'll see it in there. So it's already in there. It's really not that big, and it gets gzipped. So it actually can reduce your bundle size because it can gzip all those reduce methods to A or R. But a lot of times, again, it comes down to cost. They're like, oh, well, we have to pay for bandwidth. And it's like, okay, or we have to pay for EC2 instances, and we don't want to expand our website because it's expensive. So the largest EC2 instance, a C5A.24XL, has 96 vCPUs, 192 gigabytes of RAM, and 3.8 terabytes of NVMe storage, and it costs $14,000, $13,600 a year, which sounds like a lot of money. A storage server for your database, 36 vCPUs, 244 gigabytes of RAM, and 48 terabytes of hard drive storage, $13,850 a year. How much does a developer cost per year? The median salary in the US is $106,000 a year. And so if you have a single developer maintaining your application, and all they do is fix bugs, you're spending $106,000 a year. If you sacrifice size, you can spend $13,000 a year. You sacrifice speed, you can spend $13,000 a year speeding your application up. If you sacrifice maintainability, you have to hire more developers to maintain your app and write code for your app. I would rather throw hardware at the problem than have to hire additional developers to handle bug fixing, personally. A single source of truth drastically increases your maintainability because there's one place that your developers have to maintain your business logic. There's one way to do it. And so your bug count comes down, your developer screw ups reduce because they aren't rewriting front end code. Your regressions reduce. It's great. Maintainability is what we should strive for as developers because we can throw hardware at speed and size. We can't throw developers at speed and size, right? We can't throw hardware at maintainability. So onboarding a new developer, right, is another thing that costs a lot of money. $106,000 a year you're spending on a developer. The quicker you can get them producing code, the less sunk cost that is. If it takes a month to onboard a developer, you've spent 106 divided by 12 is roughly, I don't know. Let's for easy numbers, let's say a tenth of the year, right? $10,000 if it takes a month. If you do it in 2 weeks, you're saving yourself $5,000, right? If you do it in 1 week, you're saving yourself $15,000 or $7,500, right? The quicker you can onboard, the less sunk cost there is. There's one place for them to find all the business logic, right? If I want to teach a developer how to add an item to the cart, they can go look at the actions and find the cart add, and they can trust that if they call that, it's going to get in the cart. They don't have to learn this crazy React context that you've custom written or an Angular crazy data binding that has things over here and here's where we store it. It's, hey, it's there. You call this method and it works, right? There's less patterns to learn. They don't have to learn your way of doing it. It's call it. That's a method. It does it. Trust it. Code reviews become easier. There's less code to review. Therefore, there's less code reviews. Therefore, it's easier to develop. So inevitably, you will rewrite your application, your front end. It's going to happen. No UI I've ever seen is the same UI as 10 years ago, or even 2 years ago. The business wants to try new things out. People go, hey, what if we swap this? What if we took this form and we split it up into 2 and we do a wizard style thing? Does that increase conversion, right? Someone comes in and goes, hey, I really want this new data view for reporting. It's like, cool. Or, you know what? The business that report isn't working for the business. We need to change it to look like this, right? It's going to change. The business model is not going to change often. The business is still going to continue operating the way it operates, and they might add features, but it's unlikely that Amazon is going to turn around and go, you know what? We don't need carts anymore. Or, you know what? This cart item that's in there, well, it doesn't work, so we're going to rewrite the implementation of that, right? Now cart items are bundles. Like, that's a huge feature and a huge core change to the business. Those are way less likely than UI. So separating out your UI from your business logic makes it much easier to rewrite and adapt to the ever-changing needs of what the business asks for. You know, a supervisor's view is different than a worker's view, right? That multiple UIs exist even within the same application, but they're still doing the same things. They just have different views, right? Putting all your logic out in a global state lets you do that. So let's talk about some best practices. When you write your global state, doesn't matter whether it's Redux, RxJS, whatever role you're on, make sure that functions that manipulate the state are pure functions. Google what a pure function is. The definition is very clear. It's given a set of inputs, the output from the function is the same no matter what, which means that your function can have no side effects. Okay. We need query segregation. And I realize that I have individual slides for all of these. So we're going to talk more in detail. We need to separate rendering from business logic. We need persistence, we need tests, and we need integration tests. So let's talk about pure functions. Do not modify arguments. Get that out of your mind. Never do that again. Never, ever, ever modify the argument. If you get an object in, don't change the argument. It's bad. It's very, very difficult to debug. It's very, very difficult to work on. Don't modify, create new. They have 0 side effects, which means they cannot do things like fire an AJAX call, because that means that the state was not pure, right? So if I have a state that exists and I do an AJAX call, and then take the result of that and merge it into the state, now the results of the AJAX call could manipulate my state. And if I try and replay that, there's no guarantee that I went from state A to state B, because the AJAX call could fail. The AJAX call could read data from a database that's now not the same data, right? There's a lot of things that can go wrong, so we can't have side effects. The inputs manipulate the state, the output, which leads us to predictable output for all combinations, right? It's not just the happy path is predictable and the sad path could be wrong. It's no, every input, every output is mapped. It makes it very easy to test, because you can write unit tests and say, if I have 3 items in the cart and I add an item, I have 4 items in the cart, right? There's 3 numbers in computer science, 0, 1, and n. If I have no items in the cart and I add 1, I have 1. If I have 1 item in the cart and I add 1, I have 2. And if I have n items in the cart and I add 1, I have n plus 1. Right? Those are the 3 cases that you should test, at least, right? 0, 1, and n. So 3 versus 4, they're both n. But you can test all those cases. We can test that, hey, if I fail adding an item to the cart, the state has an error, right? If my cart item already exists in the cart, it should error, right? There's lots of things you can test, and you want to test all the cases to prove that your business, that logic, works for what the business wants. Query segregation. So we've talked about writing data to the store, but what about when we read from the store? So your logic exists somewhere in memory. And when you read data from that, you are reading it so that you can project it onto a view, right? The data exists here in logic, and you're reading some data out of that and you're projecting it up into the view. When you write those projections, when you write that read, make sure that you are separating yourself from the way the data is stored in state, right? So let's say you have, again, a cart with a list of line items, right? Instead of directly from the store reading cart and taking it back and expecting the cart to have a list of line items and passing that into your React component or your Angular component, write a function called getCart that's local to that view that takes the state in and projects it into a list, a cart, and a list of line items. Even if your state is exactly the same, having that single step, that single redirect step, that extra function means that if later someone comes in and line items are now, they go from being an array to a keyed object, all you have to do is rewrite that one function. And your view continues working off an array of object or an array, and your state has a keyed object. It makes it very easy to manipulate either side of it without affecting the rest of the application. And even if it's a direct match, put a function in there that returns identity. Like it sounds absurd, but doing it will save you so much time in the future where you can go, oh, yeah, here's all the functions I need to update. Everyone that read from this area and state needs to update. Separating rendering from business logic, right? Again, we render based on the store, we dispatch actions to the store. UI actions, whether or not a modal's open, drop-down visibility, values of text fields, those are not business actions, right? A modal is not business logic. So keep that stuff away from your business logic. Now, there are some things that are global state, but not business logic, right? Error modals are global state. You want one error modal on your page that you can dispatch to and say, hey, show this error. We don't need 500 error modals for every individual component, right? Full page loading spinners, those every site has one now. Headers, current users, that type of stuff, that's all global state, but it's not business logic. So make sure that in your global state, you're keeping your UI state separate from your business state. Don't put the mobile cart view visibility on your cart in state. It's separate. One is the business data, and one is whether or not the mobile UI is open or the pop-up UI is open, right? Keep those separate so that when someone else reads the cart state, they don't have to ignore that random modal. Or even worse, someone accidentally expects that to be part of the cart state and you refactor the modal and now it's missing and their code breaks, right? For me personally, in Redux, I drop a UI slice, and then all my UI stuff like modals and stuff like that lives under there. So it's very easy to new developers to go, oh, that's a UI thing. I shouldn't rely on that. Persistence. How many times I've heard, quote, just save it to local storage? So many times. You have to be very, very, very careful about what you persist to local storage. There's an application I worked on where they just saved it to local storage, and they wrote the entire Redux state to local storage, including the UI state, including the modal openness. And so there existed a bug where during loading, they had a full page loading modal that blocked all interaction with the page behind, and you couldn't escape or click out of it. And so if you loaded that modal and then you refresh the page while the modal's open, well, it kills the AJAX request, and the page refreshes, and the modal's open, and there's no AJAX request living that can kill the modal. And so the only way to clear that was to walk a user through over the phone how to clear their local storage. And if you've ever tried to explain to a non-technical person how to clear their local storage, it's incredibly hard. And we're getting dozens of reports of this. It was terrible. Make sure that you don't persist UI state. Just persist what makes sense. And so the other problem that often comes is people use global state like a database, and they trust what's in there. And the problem with that is it's not a database. Global state is a cache. It is data in the front end that exists so that you can easily read it and you don't have to wait on queries from the database forever. Treat it like a cache, not a source, not a database, right? So every view should dispatch an AJAX call to go retrieve the data it needs and then update the global state with the data when it retrieves it. Now, React, for instance, when you render your first report, if there's already some data, it's going to render with the stale data. While in the background, it's already dispatched a request to update the data. And then when the data comes back, the view refreshes with the new data. It is almost a cardinal sin to be like, oh, we already have the data in the global state, so we're just not going to submit an AJAX request. Because that very quickly leads to there's a page that you have to hit first to load all the application data, and then you can use the application like normal. And if you refresh, it goes away and you have to go back to the first page that loads all the data. It's really hard to work with and debug, and it's just a mess. So please, please, please treat it like a cache, not a database. So test, test, test. Everything can be tested. Everything should be tested. I love unit tests. Unit tests are great, and they're a joy to work with once you've gotten there. If you're going to be lazy and not write UI unit tests, that's okay. If you're just can't manage to do it. If there's one place to test your business logic, test your global state, because that's the part that determines the actual functionality, not so much the rendering part. The rendering part, that changes day to day depending on what colors your UX designer likes and whether or not they want the button here or there, right? That changes. Your application doesn't. Your business logic doesn't. So test the part that changes the least, the most. Verify your business logic with your product owner. Write your tests in a way that you can bring them to your product owner and say, hey, are these correct? It builds trust with your product owner that they can turn around and go, hey, you know what? I thought of a new test, or hey, that test, we need to change it because I didn't understand that, and I went and talked to so-and-so, and this is what it should be. It makes it very easy and self-documenting. Additionally, if you really want to, you can just hand the product owner your repo and go, hey, go read these tests, right? Verify for me that what we've done is correct. Because they're not UI focused, they're unit tests, and unit tests run an order of magnitude faster than integration tests that have to do rendering, even if you're using JS DOM or some fake headless DOM. Unit tests are way faster. You can write more of them and have less of an impact than having to write a bunch of integration tests. And make sure that when you're testing, you're verifying the data and not the code. So when I say that, I mean test that the data is what it is, not that your code executed in the right order. So a good test would be like, hey, when I add to cart, I expect the cart to have a line item. A bad test would be when I add to cart, I expect the function to have been invoked and then this other function to be invoked, right? Now, turning around and saying, I expect it to be invoked with this data makes it a better test because now you're testing, yes, I verified that this side effect happened with the correct data, right? We want to verify that the data flows through the function correctly, not that the code is what it's written, right? If your unit test looks like your code that it's testing, it's probably a bad test. So test the data flow is correct. So integration tests, these you want to test the user's interaction, how the user uses your code. And what's business logic is important, right? If the color of the button is super important, like it's gray versus orange for different things, cool, test that if that's a business piece. But we don't need to test CSS verification or anything like that. What we want to test is when the user fills out the text field and hits the submit button, then something happens, right? And we want to test general user flows. So how does the user use the application? If you have an A or B search field, test both of those. You don't need to test exhaustively all the errors that can possibly occur on in the form, right? You can test, yes, all the fields are verified in one test or are required in one test, right? Don't fill the form out and hit submit and make sure that each one of them has an error, right? You don't need to test that, oh, if this Ajax error fails, we get a error message. If this one fails, we get an error message, right? It's just, hey, if any of them failed, an error message pops up displaying, right? We want to test the user's interaction, not so much the business cases. Those are already tested in our unit tests. We don't need to replicate the tests over in the UI. And the way we do that is we execute a bunch of actions, fills out the form, hits the submit button, says next, right? We go through a bunch of steps and then verify that the final state exists. If you put it in global state, it's very easy to go, hey, is my application state correct, right? If it's not in global state, you have to do things like read the DOM and verify that text appears where the text is supposed to. It makes it very difficult to verify. This is one of the few places that you might want to consider snapshot testing. I'm not a fan of snapshot testing because it's very brittle and oftentimes you just ignore it. It goes, yep, we changed the UI, blow away the snapshots and commit. And that happens every time, which means that you no longer are really using snapshot testing. You're just putting a hindrance on your developers to commit. Again, you don't need to test every edge case if the unit tests cover them. And really what your tests, if you've got unit tests for all your parts, your component tests are really just testing the glue of the pieces. It's testing that, yes, I got the state from here and I passed it there because I know that this returns the right data all the time. And I know that if I give this part the right data, that it will work all the time. So I just need to make sure that I gave it the right data, right? That's the only part I need to test, not all the combinations between the two pieces. So, questions? That's all I got.
Yeah, actually we do, Eric. We got several questions.
Oh man. Okay.
All right. Got to get a drink in. Here we go.
I can see those.
Yeah. How do you make front-end state management less messy or complex?
By decoupling it. The front end state management, the global state management should be focused around your business logic. So if you have a complex business domain, it's going to be complex. There's no way getting around that. If it's a simple business domain like add to cart, stuff like that, build them simple. Don't try and make it complicated is the best way I can explain it. You want to ensure that you're only doing the bare minimum that the business requires in your global state management. So on an add to cart, you want your global state management to add to cart, not add to cart and show a modal and do this and do that. You want to add to cart. That's the business logic. You can then compose that into another thing that says, hey, we're going to add to cart and show a modal, right? It becomes very small. You have one part that has the complex add to cart logic and one part that has the complex show modal logic, and then you have one small part that combines the two together. You end up with a lot less big hairy pieces because the only big hairy pieces are the business parts. So reducing the amount of complexity, making smaller functions that you compose together makes it a lot easier to maintain and test and read, because it goes from I have this 1,000-line monstrosity to, okay, I have a function that calls 15 other functions, but they're named fill out or send to, create line item, add line item to cart, recalculate price, update or show success modal, send to server, right? Purchase. Though 15 lines of that is a lot easier to read than 1,000 lines of, well, we push this into the array and we, loop over the array and count all the prices up, and then we calculate that and we dispatch this modal view and we send an AJAX request over here, and then when that comes back, we have to do all. It gets very complex that way. But if you separate them out into nice little steps, it makes it much easier to follow with.
Nice. All right. Here's one that kind of, I think, goes along with some of what you were talking about before. John asked, how do you handle sensitive data in your state? For example, a user's credit card info.
Should not be in global state. You have sensitive data is, it's sensitive, right? I would argue that your sensitive data you shouldn't be dealing with sensitive data. Someone else has already done it and maintains it. PII gets very, very sketchy very quickly. It really shouldn't be persisted anywhere. It should be transient so that it's stored in memory, and when they're done, it refreshes and it's gone. The moment you store it in state, you start having to deal with PII issues and laws. And anytime we get into legal issues, we start having issues. So just do yourself a favor and don't store it. Right? Yeah, it's a scary thing. PII is scary.
So Lance was asking, what's your opinion on using state management with forms?
I don't like it, often because it gets confusing it confuses the lines between global state and application state. So like the Redux forms, right? React Redux forms. That's one library that I've seen used a lot and is fairly popular. And the reason it's used is because it well, we already got Redux and forms suck in React, so let's just hook into Redux, right? Make it easy to read our data. It makes it easy, yeah, but it also makes it sketchy. Your form is then bound into your global state, and now you're dispatching actions that say, hey, I entered my text here, I did this there. If that form is business logic, right, then maybe it does matter. You know, if you really want to maintain an active record of every single key press the user did, go ahead, throw it in there. Put in a UI state part that says, hey, this is UI over here, right? But make sure you actually need it. You know, for instance, as an alternative to Redux forms, React hook form does a lot of the cleans up forms in a way that still uses the UI's state management, the just built-in React state management, but gives you an easy way to in nested components hook in and grab data values and submit all at once without having to do prop drilling and stuff like that. And again, it makes it a little easier without forcing you to be tied to state.
Got it. All right, this is the last question that we have from Will. When treating global state like cache, how can you ensure correct state if the UI allows rapid line item changes, but the server is enforcing concurrency against a domain object that owns those individual line items?
It depends. So you have to decide this really comes down to a business requirements, right? So the simple solution is don't care, right? Don't care about stale data. Submit it all, and when it comes back, it resolves, right? Eventual consistency. This is a concurrency problem, not a front-end state management problem. So removing state management from this, right, entirely. Let's just talk about a database. You submit data into a NoSQL database, and you have another service that listens to that event and updates its view. It's all eventually consistent, right? You have to realize that the data you're dealing with is eventually consistent and properly alert users when things go wrong, right? So you let the user operate as if everything's working, and when the server kicks back and says, hey, that thing you did 5 minutes ago didn't work, you, as a business, you have to decide, okay, what happens, right? Because anytime you're dealing with rapid line item changes, like the easiest way to think about it is say, okay, let's say they're not rapid. Let's say they're once every 10 minutes. Slow it down, and then let's say something errored 10 minutes ago. How does the business react to that, right? If you can recover from it 10 minutes ago, you can recover from it a millisecond ago, right? But it really depends on how the business wants to handle a conflict, a data conflict.
Got it. Well, that's the last question. I just want to say, thank you guys all for attending the Lunch and Learn today. And Eric, thanks for sharing. As always, the recording of the session will be available on our virtual events page at improving.com/virtual events. Have a great weekend, everybody. Again, thanks, Eric.
Thanks.